Hello, my name is Uday Naik, and this is a 15-minute video presentation for the course E63 Big Data Analytics. The topic of my final project is Graphx graph processing on Spark. So within the company, we have a social networking site called Rabbit, and on this site there are users, and the users have other users who are followers. This project is to analyze the user and the follower data using graph processing tool Graphx on Spark. So before we jump into the code, we want to present a little bit of background about the technology we are using. So what is Graphx? Graphx is a Spark API for graphs and graph parallel computation. Graphx extends the Spark RDD by introducing the resilient distributed property graph. The goal of Graphx project is to unify graph parallel and data parallel computation in one system with a single composable API. We'll talk a little bit more about this more in next one or two slides. The Graphx API enables users to view data both as a graph and collections without data movement or duplication. This is another very important point about Graphx that separates it from other graph processing technologies. We'll talk about that a little bit as well. So what is graph processing? Graph in data terms is simply representation of individual entities and their relationships. The graph entities are known as nodes or vertices, and relationships between entities in graphs are known as edges or connections. So in our example, the users are the vertices. When one user follows another user, the path that links one user to another user is called as an edge or a connection. Graphs can be used to identify influential people and information. So in the example that I just mentioned with users and followers, if you extended that to a large social networking site like Facebook, you can identify influential people and information. You can find communities, you can understand people's shared interests, and you can model complex data dependencies. Some of the applications for graph analysis, a great example is Google's PageRank algorithm, Facebook's friend recommendations, and LinkedIn's degree of separation. So when Facebook recommends somebody as a friend, or when LinkedIn identifies the degree of separation between one person and another, they are doing graph processing or graph parallel computation to figure out the answers to these questions. So the big data world breaks out into two. One is data parallel and one is graph parallel. The data parallel world we are a little more familiar with technologies like Hadoop and Spark. For graph parallel, we need a separate system to optimize the performance. Now when we build this separate system, it is difficult to use and it is inefficient. Graph parallel systems are highly performant for graphical computation. However, they have limitations. It is difficult to express important stages in the graph analytics pipeline, like constructing the graph, modifying its structure, or expressing computation that spans multiple graphs. Also, very importantly, it is often necessary to move between a table view and a graph view of the same physical data. With these two technology stacks like data parallel and graph parallel, that is not possible. So examples of graph parallel systems are Pregel, Apache Giraffe, and GraphLab. They exploit the graph structure to achieve orders of magnitude performance gains over more general data parallel systems. Graphx solves the problem with data parallel computing and graph parallel computing. It is a unified approach for graph parallel and data parallel computation in one system with a single composable API. The Graphx API enables users to view data both as graph and as collections without data movement or duplication. So on the right hand side, if you see, there is pre-processing. On the left hand side, there is data with pre-processing. Then there is ETL, then there is slicing that happens, then computation of an algorithm like PageRank, and then the analysis to get top 10 users. And you repeat this across different streams. Coming back to my project, we have mined two pieces of information. One is the follower information, which has one user following another user, and these are basically a list of numbers separated by a space or a tab. And then there is a second list which has the user information, and in this particular case we are capturing the user ID and the user first name, but ideally you can capture a wide variety of information about the user, including age, their geographic location and such. And when you do these computations, essentially you can mine very important information about a particular user-follower combination. For example, when a group of users follows a certain other group of users, is there any age association or is there any geographic association associated with it? The technology stack that I'm using, the hardware setup is my Windows machine with 8 GB RAM and a 3.2 gigahertz CPU. And on the software side, I have Cloudera, CDH, Apache Spark, Scala, Graphx, and Java 1.7. I also installed Scala IDE because I found out that the Graphx API's support on Java and Python are not very strong, but on Scala they are pretty strong. So we'll start to look at some code now. In this particular example, I'm going to build a graph for some user and follower text files, then restrict the graph to important relationships and users, run PageRank on the subgraph, and then finally return attributed associates with top users. And with the power of Graphx, I can do all of that in very few lines with Graphx on Spark. So this is my Cloudera VM that I have installed on my PC, and I have two Windows terminals open currently. Let's see the files in this folder. So I have home Cloudera FP as my current folder, and the files that we are interested in are the two input files called u.txt and f.txt. So these two files are the ones that form the input of the project of the code. So they will take the data from here and then process it. Let's see the content of u.txt. So as I mentioned, this is a list of users and it has the user ID and name information in there. Similarly, let's see the information associated with followers. And in this case, it has the information related to which user ID follows another user ID. Pretty simple basic stuff, but it has information related to both. The number of users and followers combination is 154,000, and number of users that I have is 154,000. So pretty much same number of users and they are following each other. Now on this machine, I have Spark installed, I have Scala, and I have JDK. So if I do it will point me to the /user/bin Spark shell user. It will point me to the version of Java which is 1.7.0.67. And if I say which Scala, it will point me to version 2.11.6. If I look at my .bash profile, this is how it looks. So I've set up my Spark home, my Scala home, and my path is all set. So in this example, what I'm going to do is I'm going to launch a Spark shell and enter the commands online on the Scala prompt. So here we go. Now this takes a little bit for it to load as it thinks. Okay, now that we have the Spark shell loaded, we will start by importing the libraries. So I'm just copying from here and pasting here in this Scala shell, and the libraries are loaded. Now we'll load the user data and parse it. In our case, the attribute list is pretty short, uh, but we could have multiple attributes. Like I mentioned earlier, we could have age, geographical information, their location, their demographic information. But in this case, we just have user ID. So I'll cut this, paste it, and the file's loaded. The next thing we'll do is we'll parse the edge data, and edge data is essentially the connectivity between 2 points or 2 vertices, which is 2 users in our case. So this is the follower information. That loaded. Now we basically attach the user attributes. Successful. We will restrict the graph with usernames and names, and I mentioned we have that we do not have anybody without a username or a name. So in our situation, essentially it's moot point. We'll run it. We will compute the page rank here. This is the page rank algorithm, and this 0.001, if you are interested, we will not cover it now, but basically this is the page rank algorithm that will run. I'm going to cut and paste, and this is the point where it runs and will do its job. It's still running. As you can see, the clock, we started at 39 and it's 16:41, so 2 minutes. Just quick checkpoint, 16:43:09, and it is still going. Alright, so after 7 minutes it completed, and let's execute the last remaining piece. And we will get the attributes of the top page rank users, and we are now ready to print our information. Okay, Now that it started, it stopped processing and wrote a file. Let's see what it wrote. So it did identify the top 5 users and their attributes. So this is the end of the video of Graphx processing with Spark. Thank you for your time.